Hey, in this video I'm going to show you how to make a simple networked FPS game with Godot 4 and Blender 3. I'll walk through it one step at a time, so check the timestamps in the description if you're only interested in certain parts. This project uses something called Universal Plug and Play, which should work for most people out of the box, but you may need to check your router settings at some point to make sure that UPnP is enabled. I'm no networking pro, this was just the simplest starting point to online multiplayer I could find, and I had a lot of fun making little projects like this. So if that sounds interesting to you, let's get started. Okay, I've got a brand new Blender file open here, and I'm going to make an environment for the game really quickly. So AX to delete everything, then Shift A, Mesh, Plane, S10 to scale that up, Tab into Edit Mode, Control E, Extrude Edges, right click to keep them in place, and then S2 to bring those out, GZ to just to give them a little bit of height there. And then E, right click to extrude those edges in place, S 1.5 to extrude those out, and then EZ for enter, just so that there are some walls so the players can't walk off the edge of the world. Okay, tab back into object mode, then go down to this menu here, give it a new material, this will come into play later, and then let's give this environment a couple more objects just so that it's not so boring. So Shift A, Mesh, Cylinder, and then I'll go down here, I'm going to give it a radius of 1.5 and a depth of 4, then GZ2 to bring it up to ground level. Actually, I'm going to hit Shift Tab to turn snapping on, so that simplifies moving things a little bit. Numpad 7 to go to the top view here. I'm going to move this one up to the middle of this corner, so G, and just drag it right there. Shift D, and I'm also going to put one up in this corner, and then GZ, drag it up so that's actually on the ground there. And now we're also going to add some platforms here, so you could maybe, jump on this pillar here. So Shift A, Mesh, Cube. Okay, GZ to bring that up there, and then SX5. I'll go to the top view again, drag it over just so it's perfectly in the ramp, just like that. Shift D to duplicate it, RZ90, G, and then drag it over to this side. Okay, perfect. Now I'm going to click all of these, and I'm going to duplicate it so that it's on all edges, or all of the corners, I should say. I'll go up here, select 3D cursor, and then Shift D, RZ, 90, and then do that 2 more times. Shift D, RZ, 90. Okay, perfect. So now hit A to select everything, and then shift click, make sure that this plane object, the floor, is the last selected one, the active selected object. Then Control J to join all of them together. Tab into object mode, you can just press A to select everything, and we want to select everything except for the plane vertices, so I'm going to go over to one of those vertices here, and then hit Shift L to deselect all of the linked geometry there. And then in this material tab, hit this plus button to add a second one, new material 2, and then hit assign. So then let's just check here. So material 1, select, yep, it's all of the ground vertices there. Then material 2, select, it's everything else. Okay, that's perfect. That's exactly what we want. We're going to apply prototype textures to these objects in the engine, and having them separated in these two materials will just simplify that process. Okay, so the last things that we're going to do is add -col to this so that it automatically has collision on import to the engine, and then I am going to select it, Control A, apply all transforms, and then I'll just save this as environment.blend, and we are done. Alright, I've got another new Blender window open here, and we're going to model a pistol for the players to use as a weapon. So I'll click the light, shift click the camera, delete those. We're going to start with the standard cube here. Click the cube, S, Shift Z, 0.5, S, 0.1 to shrink that down, peer to the numpad to zoom in, tab into edit mode, and we're going to extrude the barrel down the positive y-axis. I'll press K to go to the knife tool, and then shift click these edges to put those vertices in the middle, enter, 3 for face select, click the top one, E, 0.2, and then I'll click this bottom face here, GY, drag that back a little bit, 2 for edge select, click the bottom edge of the barrel, GZ, drag that up a little bit, tab back into object mode, go to the wrench, add modifier, let's add a bevel modifier to it. I'm going to turn it up to like 0.15, okay, and then I'm just going to apply it like that. And it's a little wide, so SX, let's scale that in a little bit. Okay, perfect. Tab back into edit mode, 3 for face select, click this back face. I'll scale it into about here. 2 for edge select, click this bottom edge of the new face, and then G twice to lock it to the edges that it's attached to right now. Drag it up to about there. 3 for face select, click the face, E, extrude it out to about there. Again, edge select mode, bottom edge, GG, drag it up about halfway, and then we've got a hammer for our pistol there. Okay, and then 3 for face select, I'll click the end of the barrel here, Shift S, cursor to selected, and then Shift A, cylinder, and then this is way too big, so I'll make the radius 0.05 and the depth 0.05 as well. RX 90S, let's scale this way down. Okay, and then it's out a little farther than I'd like, so SY. All right, and then 3 for face select, click that end face of the cylinder. E, right click to extrude in place, and then S, let's scale that face in. And then X, delete only faces, and we've got everything modeled. Now we just need to take care of the materials, and because this is the starter cube, it already started with one material, so let's just call this one pistol black. In the viewport, I'll press Z and go to material preview, and then for the base color here, I'll drag this down, not all the way, but pretty close to black, and then specular, I'll drag down to maybe around 0.1. Then I'm gonna add one more material here, and I'll call this one pistol gray. And the base color for this one, I'll make this like 2/3 of the way down like that. And we're going to apply the tip of the barrel and the hammer to have this this gray. So I'll go into edit mode with the tab, and then I'll press L over that cylinder geometry to select all that. And then with face select mode on, I'll shift click all these faces, and then with all of that selected, make sure you've got pistol gray selected there, and then hit assign. And there we go. Control A, apply all transforms when you're in object mode, and then Control S, and I'll save this as pistol.blend, and we're done. All right, I've got a new Godot 4 project open up here, and we're going to start by importing some assets, including the environment and pistol models that we just made, and we're going to import them as blend files. But in order to do that, we're going to have to go up to this editor menu here, go to editor settings, and then in filter settings here, you can search Blender, go to this import tab, and this Blender 3 path is going to have to be set to the directory where your blender.exe is. So here, you can see that this Blender Foundation folder is where my Blender versions install by default. So in Blender 3.3, this is what I'm currently using. This is where the blender.exe is. So you're going to need this directory listed here. And if that's giving you problems, you could also just export your models as GLTF, like I do in my previous videos. So if this isn't working, just go ahead and follow that process in my previous videos. But I've got this set, so I'll continue. So I'm going to take these blend files, select them, and just drag them in here, and then Godot is going to import them. Okay, and then I'm also going to import some things from the asset library. I'm going to import some textures and some particles, both of which are made by Kenny. So the prototype textures and the particle pack here. So I'll click the prototype textures, click download, and then I'll just install all of it. Okay, and then I'll do the same exact thing with the particle pack, download, and I'll just install all of it. Okay, and we're good to go. Now that we've got everything imported, let's go ahead and set up a basic environment scene. So right-click environment.blend, new inherited scene, click this plane mesh instance, and then over here in the inspector, surface material override, surface 0 is going to correspond to the floor and the walls, and surface 1 is going to correspond to that second material that we made, the one for all of these extra objects that we added. So for surface material 0, new standard material 3D, go into that, albedo, and then in our add-ons folder, Kenny prototype textures, I'm going to give it a dark texture, and I'll use texture _ 09. I'll drag that into the texture field there, and then in UV1, click triplanar. That just makes it so that the texture is projected on, and it looks a lot cleaner. And then for 1, new standard material 3D, same exact thing, go into albedo, and then here I'll go with an orange one instead, texture _ 10, and UV1 triplanar. Okay, I'll save that, environment.tscn, and then let's put this together in a basic world scene. So other node, I'll just make it a root, a normal node, call it world, Control-Shift-A, add environment.tscn, and then I'll click these dots up here, add environment to scene, add sun to scene, and we are looking good. Control S, and I'll save that as world.tscn. Now that we've got this environment set up, let's set up a player scene so we can actually move around it. So I'll hit this plus button, other node, character body 3D, I'll call it player, Control A, add a mesh instance 3D, and then I'm also going to add a collision shape 3D. For the mesh instance, I'll give it a capsule mesh, and the collision shape, I'll make a capsule shape. I'll shift click both of these, hold Control, drag that up 1 unit, just so that the bottom of the capsule is at the root position. Then on the player, Control A, I'm going to add a camera 3D, and then I'll drag the camera up till it's right about there on the capsule. Then I'll click the player node, add a script, make sure you've got this template checked for basic movement. I'll create that. Currently the movement is mapped to the arrow keys, but I want to use WASD instead, so I'm going to add some new actions. Project settings, go to input map, add new actions, up, down, left, right. I'm also going to add a quit action, up, W, down, S, left, A, and then right. I'll map to D, and quit I'm going to map to escape. Okay, and then here I'm just going to remove all of these UI underscores, and then this will be mapped to WASD instead. Okay, I'll save this scene, and then I'm going to go back to the world scene here, click the root node, Control Shift A, add that player scene, hit play, select current. Okay, so now I can move the player around, but we need to lock the cursor and make it so that when we move the cursor, the player rotates along with the camera. So I'm going to close this out. Also, when we lock the cursor, it does become a little bit of a nuisance to close the game. So on the world scene here, I'm going to add a script, and then I'll add a unhandled input function, and if input.isAction just pressed quit, get tree quit. So now I can just press escape and quit whenever I want. So I'll save that. I'll go back to the player script. Let's lock the cursor. So up top here, I'll add a func_ready function, input.mousemode equals input.mousemode captured. Let's take a look. Okay, so now the mouse is captured, and if I hit escape, I can close out. Now we just need to handle the rotation. So up top, I'm going to get a reference to the camera at onReady var camera equals camera 3D. And then under this ready function, I'll add another unhandled input function. If event is input event mouse motion. And when the cursor moves from left to right, we're going to rotate the player on the y-axis. So rotate y negative event dot relative dot x, and then I'll multiply that by 0.005, and then I'll copy this, and on the line below, camera dot, and paste that. When the cursor moves up and down, we're going to rotate the camera on the x-axis, so I'll change this rotate y to rotate x, and then the relative x to relative y, and we just need to lock this number to a certain range, otherwise the character's camera could like somersault forward infinitely. So under that, camera dot rotation dot x equals, and I'll copy this, clamp, and paste that, and then comma negative pi over 2, pi over 2. All right, so I'll save that. And now we can move around, and the player can look up and down, and everything works as expected. The movement isn't great, and there's a lot of things that you could do to this controller to make the movement better, but that would be a little bit out of the scope of this video, so we're just going to tweak a couple numbers and call it there. So I'll hit escape, and I'm just going to change the speed to 10, the jump velocity to 10 as well, and then I'll set the gravity to 20. And for our purposes, this movement is going to work just fine. We can move around a little bit more quickly and jump up around the environment a little bit. Okay, so that's a wrap for the character movement. Next up, we're going to give the player our pistol mesh as well as some animations. So I'm going to go back to the 3D tab over here, click Camera 3D, Control Shift A, give it a pistol.blend as a child, and then in that transform position, I'll set to 0.5, minus 0.25, minus 0.5. I'm going to click View up here at the top of the viewport, select two viewports Alt, and then I'm going to open this bottom panel here as well. And I'll click Camera 3D, click Preview on the right, and then I'm going to adjust this until I can see the full yellow outline here. So this is what the player is going to see from the camera. I'll click Pistol over here, center in on that, zoom in there, and now let's make some animations. Player, Control A, add an animation player node here. Animation new, let's make an idle animation, and let's make it 3 seconds long. So I'll click Pistol, and then I'll key position, create a reset track, same with rotation. Okay, then I'll go halfway over here, and I'm going to rotate it forward in the x-axis a little bit and move it down on the y-axis just a tad. Then I'll key position and rotation again. I'll select all of those, and then over here I'll right-click on easing and set that to ease in out. Click this to set this to looping, and I'll make this autoplay as well. Let's see what this looks like. Alright, that looks pretty good, so I'll stop. I'll go to reset, and then animation new. Call this one move. 1 second is fine. I'll set the snapping to 0.25, and then at 0 seconds here, I'm going to key the position. No need to create a reset track. At 0.5, I'll do the same thing, and then at 0.25, I'm just going to move it a little bit to the left and a little up. I'll key that position, and then 0.75, a little bit to the right, a little up, and I'll key that. And then, so at 0 and 0.5, I'll shift-click both of those. I'll right-click and I'll ease out on both of those. And then the other two, shift-click them, and I'll ease in on those. I'll also set this to looping. And that looks good to me. So I'll stop that. Again, go to reset, animation new, one more animation here. I'll call this one, oh, let's get rid of that one, not shot. I want to call it shoot. And I'll make this one 0.4 seconds. And I'm going to key the position and rotation here at the end of the animation. And then I'll go to the front. And for this one, I'm going to pull it back on the x-axis a decent amount. And I'll pull it up a little bit. And then I'll key position and rotation. And I'll select both of those. And I'm going to ease out. And this one doesn't need to loop. And that looks pretty good to me. So I'll save that, and we're done with our animations. So we've got our animations set up. Now we just need to add some logic in the player script so that those animations play under the right circumstances. I'm going to start by clicking the animation player node, and then in playback options, I'm going to set the default blend time to 0.05. This is just going to make it so that when we swap between these animations, they automatically blend for a little bit, and it's going to look a little bit smoother. Okay, so now let's go into the player script. I'll close this panel here, go up top. Let's get a reference to the animation player at onReadyVar animPlayer equals animation player. So if the player is moving and they're on the floor, we're going to play the move animation. Otherwise, let's play the idle animation. I'm going to put that logic right here above move and slide. So if input dir is not equal to vector2.0 and is on floor, animPlayer.play move. And then if that's not the case, else animPlayer.play idle. So let's take a look at that. Okay, so we start with the idle animation. When we move, it swaps to that. When we jump, it goes back to idle. Okay, perfect. So now we just need to add shooting. So we're going to start by adding an action input for that. So project settings, input map, add new action, shoot. Down here, I'll map it to mouse buttons, left mouse button. Okay, and let's detect this input in unhandled input right here. So if input is action just pressed shoot, and we're going to use the animation length of shoot as the cooldown for shooting, so we need to check to make sure that that animation isn't already playing. So and animPlayer.current animation is not equal to shoot, and this is a little bit long, so I'm going to add a backslash here and tab that over. So here it will be, we'll make a function called play shoot effects, and then let's make that function down here. So func play shoot effects, and then animPlayer.stop. Whenever I'm doing important animations like this, I typically will stop the animation player first. It can be a little finicky sometimes. So animPlayer.play shoot. And currently, move and idle will override this in the physics process function, so we just need to check to make sure that this isn't playing before we swap to these. So up here, I'm going to add if animPlayer.current animation is equal to shoot. I'll pass, and then I'll change this to else if. And so with that, okay, we're good with idle and move, and then if I shoot, the shoot animation plays, nothing's overridden by it. Okay, everything's looking good, and all we need to do is add a muzzle flash. Okay, so let's add that muzzle flash. So I'm gonna go back to the 3D view here, back to one viewport, and close this panel here. I'll click Pistol, Control A, add a GPU Particles 3D here. Let's call it muzzle flash, and then let's have it positioned right in front of the gun barrel like this. Try to center it, okay. Then over here I'll set the amount to 1. For drawing, make sure you've got local chords checked. Process material, new particle process material, and then in gravity, set that to 0. Draw passes, pass 1. Let's make a new plane mesh and have it be 0.5 by 0.5 meters. Set the orientation to face Z, and then a new standard material 3D. Okay, and then I'm going to save this. Currently in Godot 4 beta 12, there are some known bugs with GPU Particles 3D and spatial materials that will cause the engine to crash, and I'm sure that these will be fixed soon, but one workaround that I've found is I'm just going to close the scene and then reopen it, and then I'll keep going here. So I'll go back to that material and billboard, I'll set the mode to particle billboard, and then in albedo, the texture that we're going to apply here is star_06 from the Kenny particle pack, so I'll drag this in, and then I'll apply this yellow-white color to it. And then transparency, I'll set to alpha, shading, unshaded, vertex color, uses albedo because we're going to be using the color ramp from the particles material. Okay, and then we'll go over to the particles material right here. And so color ramp, right here, color ramp, gradient. Let's go here. I'm going to add a point right here, pretty close to the left side, and I'll set it to white. And then the ones on the ends, I will set the alpha down to 0. Okay, and then I'm also going to go into angle and set the minimum to 45 degrees just because I like that orientation more. Then the last thing, I'm going to go into time and set the lifetime to 0.25, and I'll set it to 1 shot. Okay, and now in the player script, let's just get a reference to the particles. So at onReady var muzzle flash equals camera. Yep, so that node path all the way to muzzle flash, and then down in the play shoot effects, muzzle flash dot restart, kind of a similar thing to the animation player here. When I'm playing something over and over again and it's a one shot, I just find that using restart helps to keep it from stuttering. And then muzzle flash dot emitting equals true, and let's take a look. Okay, and then we've got our muzzle flash effect. Alright, so it's time to start thinking about some of the multiplayer aspects of this project, and we're going to start by making a main menu so that players can choose to either host or join an instance of the game, and then later, when we start wiring that up, I'll explain a little bit about how the logic of that all works. So I'm going to go back to the world scene over here, and I'm going to start by deleting this player node here. That was just there for testing purposes. We're going to instance them in later in a different way. And then I'm going to go to the 2D view, close this panel, and then on the world node, I'll click that and Control A, add a canvas layer, and to that I'm going to add a panel container, and I'm going to name that main menu, and then I'll give that a margin container, and I'll give the margin container a VBox container, and then in there everything else is just going to be in the VBox container. I'm going to give it a label, I'll also give it a button, and I'm going to call that host button, and then I'll duplicate that, Control D, and I'll call this next one join button. And then last but not least, Control A, I'm going to add a line edit down there. And I'll call the line edit address entry. Okay, now let's add some text here. For the label, I'll say main menu, and then I'm going to set both of these to center alignment. Host button for the text, I'll put host. Join button, text is going to be join, and then address for the placeholder text, I'll put enter address to join here, and then I'll also align that center. Okay, now let's go to the main menu and click this and select full rect for the anchors. Margin container, theme overrides, constants, give all of these 15 so it's got some space around the edges, and then VBox container, theme overrides, constants, give it 15 separation so there's some space between them. And then for the main menu, click, hold Alt, and then click one of these orange buttons here on the corner, and then just drag it in so it's nice and centered. That looks good to me. Let's make sure everything looks good. Yep, you can click these, type stuff in here. All right. Let's wire up these buttons and get some references to this. So host button, click that, and then go to the press signal here, double click that, connect. Same thing with the join button with pressed, connect. Then I'm going to remove spaces here because I only put one line between my functions, and Up here, I'm going to get references to main menu and address entry. So at onReadyVar main menu equals, and then you can actually just drag this in right over here. Okay, and at onReadyVar address entry equals address entry. Okay, and we are ready to start wiring some of this up then. Okay, so let's say the player clicks the host button. Well, the first thing we're going to want to do is we're going to want to hide the main menu with mainMenu.hide, and then we're going to have to create a server, and that server is going to have to live on an open port. So I'm going to go const port equals 9999. Typically, any port over 1024 should be open, so this will probably work fine for you. Then I'll go var enetpeer equals enetMultiplayerPeer.new, and then I'll create the server down here with enetpeer.createServer. And I'll pass in that port number. Then I'll go multiplayer.multiplayerPeer equals that enetpeer. And so now, once this runs, the server should be up and running. We just need to spawn in a player for the host. So let's get a reference to the player scene here. Const capital player equals preload, and then I'll drag in the player scene here. Okay, so now let's make a function down here so that we can actually spawn them. Func add player peer ID var player equals player dot instantiate player dot name equals string peer ID. This is going to be used for authority purposes later. And then add child player. Okay, so now we just call it from up here. So add player, and then we can get the peer ID for the host by going multiplayer.getUniqueID. Okay, so let's play this. The first time that you run this, it's probably, at least if you're on Windows, this is what it does for me. It's probably going to ask you if you want to give this application access to your private and public networks, and make sure that you give it access to public networks if you want to be able to play this online with friends later. But we can see that it's working just fine right now, so let's set up the client now as well. And I'm going to do that by copying these 3 lines right here. So I'll paste that, and we're going to change create server here to create client, and then we need to pass it an address. And because we're just testing things locally, for now we can just hard code this to localhost, and then we'll pass in the port right there. And we don't want to call add player on the join button. We only want to spawn players from the server. So how do we spawn a player when the client joins? Well, we can wire up a signal here on the server by going multiplayer.peerConnected.connect, and we'll connect it to add player. So peer connected is a signal that's going to emit on the server every time a client connects to it. So it's going to connect to add player, it's going to pass in the new peer ID, and it'll spawn one every single time the client connects. So let's go to debug, run multiple instances, and we're going to run 2 instances now. So let's see. So up here I'll host, and then down here I'll join. And so what happened here is 2 players spawned. You can kind of see the animations going together, but they are colliding infinitely and it's propelling them upwards. So the way that I'm going to solve this is I'm just going to make it so that players don't collide, and I'm going to change the player layer here to 2, then I'll remove the 1, and let's try this again. So host, and I'll actually move over here and then join. And there we go. So 2 are connected. However, the host, the server, is controlling both of them right now, so we're going to have to fix that. Okay, so a second player connects when the client joins the server, but currently they only spawn in the server and they're both being controlled by the server. So there's a couple things we have to change here, but the first thing that I'm going to fix is I'm going to spawn the players in both instances. So I'm going to go to the world scene. I'll click world, Control A, and I'll add a MultiplayerSpawner Node. Then I'll go to spawn path, and we're instancing the players as a child of this world node here. So I'm going to select this as the spawn path. Then I'll go to auto spawn list, add element, click this folder icon, and then I'll select player.tscn because this is what we're spawning and this is what we need spawned in all of the clients. So I'll open that there, save, and then let's try this again. So I'll host here and I'll move over here. Then I'll join. And then we can see that the client connects as well. And you can't see it because you can only see one player, but they're actually both spawned here. They're just both in the same exact spot because the authority hasn't been set yet. So currently we're just controlling both players, and it's still the same thing in this instance as well. So the next thing we'll do is we'll fix that. In order to make it so that the server and the client can only control their corresponding players, we need to set up the authority and connect it to their corresponding peer IDs. And since we set the player name to the peer IDs, this is going to be pretty easy. I'll go back into the player script over here, and then I'll make a function above ready called func_enter_tree. And then here I'll go set multiplayer authority string name to int, because this has to be an integer, and name actually isn't stored as a string. And then we're going to have to check for this authority in ready unhandled input and physics process. So starting with ready, we'll do if not is multiplayer authority. So if it's not the authority, return, don't execute this code. So we're going to add one more line here, and that is we want to make sure that the camera is current for the correct player character. So here we're going to say camera.current equals true. So that will make that the case. And then we'll just copy this line and we'll just drop it in the first line of unhandled input and physics process as well. And then I'll save. And then let's take a look. So over here, I'll host. Okay, and then I'll join here. And there we go. I'm only controlling one character over here, and then on the server, it's the same case, but they're not synchronized, and that's the next thing that we have to fix. So just like with the world scene and the MultiplayerSpawner Node, Godot 4 introduces a really simple way to synchronize things between scenes, and I'll add it here. I'll click Player, Control A, and it's going to be the MultiplayerSynchronizer Node. So all we have to do is add the properties that we want to sync in here. So the ones that I'm going to sync are player position, player rotation, and camera rotation, just so we can see that pistol move up and down. Okay, and that's it. It should work just like that. So I'll host here again, and I'll join the client here, and boom, up and down, left, right, see it moving. Let's check the other one. Yeah, it works. Pure magic. All right, so we've got some stuff synchronized now, but one thing that we don't is actually the shooting animation. You'll see I'm shooting in one game instance and the corresponding player isn't shooting in the other, and that's just because the play_shoot_effects function is only being called locally. So how do we call it in the remote instance? Well, what we have to do is we have to add this annotation here called RPC. But if we call this as an RPC function, it's only going to be called on the remote instance, so we also need to add something here called call local so that it's called in both. And then in order to call this as an RPC function, instead of calling the function like this, we call it by writing the function name and then writing RPC just like that. So now, if I start this up, I am shooting in both. And you can see that in the remote version of the player, the animation, the idle animation doesn't start up afterwards. So how do we do that? Well, what we're going to do is we're going to set up a signal from the animation player. So I'll go to animation finished, connect that up to the player, and then here I'll just check if anim name equals shoot. So after the shoot animation finishes, anim player.play idle. And let's just take a look at that. Okay, and you can see the idle animation resumes on the remote player as well. Okay, so we've got the necessary pistol animation set up now, but we don't have any shooting taking place in the sense that we're damaging any players or anything like that. So let's set that up now. And the first thing I'm going to do is I'm going to give the player an aiming indicator with clicking the camera and Control A, add a texture rect. Down here I'm going to search for a circle. I'm going to use circle 5 from the Kenny particle pack. I'll drag that into the texture field over here. I'll click the anchor presets here, go to full rect. Stretch mode, I'll use keep aspect centered, layout, transform, right click size, copy value, pivot offset, I'll paste that value, and then I'll divide both of those values by 2. And then for the scale, I'll set this to 0.03, and then this is going to work just fine as our aiming indicator. So now let's give the player a raycast so they can detect enemy players when they shoot. So I'll click camera 3D, Control A, raycast 3D. Over here, set the collision mask to 2 because this is the layer that we set the players to. And then target position, I'll set Y to 0 and Z to -50 so it goes nice and far in front of the player. And then I'll go into the player script. And let's get a reference to the raycast here at onReadyVar raycast equals, then I'll just drag it in right here. And let's set up a health variable as well. Var health equals 3, so I'll say that after the player gets hit 3 times, let's respawn them. So here when we're shooting, let's check to see if we're hitting a player. So if raycast.is:, colliding, then let's get a reference to the hit player. Var hit player equals raycast.get collider. Okay, and now what you might think to do is hit player.health minus equals 1, but this won't work because this is lowering the health of the local enemy player, and what we want to do is we want to lower the health of the remote enemy player, the one that has the authority for it. So we're going to make an RPC function for it down here. So down here, func receive damage, I'll say health is minus equal 1 at if health is less than or equal to 0. We'll just do a very simple sort of respawn here by setting the health back to 3 and the position equal to vector 3 dot 0. So because we're going to be using this as an RPC function, we have to put the RPC right here, and we're going to have to put another thing in here, and that is any peer, because we are calling receive damage from the player that is dealing the damage, and that would mean that we're calling it from the player that doesn't have the authority. So here you'll notice that play shoot effects, you're calling it on the player that you have the authority over, but here you're calling it on a player that you don't. So we need to add this, otherwise you wouldn't be able to call it on enemy players. So up here, I'll replace this with hit player dot receive damage, and we're not actually going to use RPC here. We're going to use RPC ID instead, because let's say that we had 4 players playing together. RPC would call it on all 3 of the remote players, and we only want to call it on the one that has the authority. So we'll say RPC ID, and then we'll pass in here hit player.get multiplayer authority, and then let's take a look. So host, and I'll move forward a little bit, join, and then if I hit them 3 times, 2, 3, they are respawned. Okay, so the players have a health value, but we don't actually have a way of telling what our current health is. So what we're going to do is we're going to add a health bar, and we're also going to move the aim indicator here to a heads-up display in the world scene. So I'm going to right-click this text direct, I'll cut, and then I'll save the scene. Then I'll go back to the world scene, canvas layer, Control-A, add a control node, and I'll call it HUD. And then I'll go over here, full rect, go to mouse, change the filter to ignore, then I'll right-click HUD, then I'll paste our text direct there. Then I'm also going to go Control-A, add a progress bar, I'll call it health bar, I'll make this full rect as well. Then I'll hold Alt and drag one of these corners in to make it a thin rectangle, drag and hold Shift, bring it up there, uncheck show percentage, max value I'll set to 3, same thing with value I'll also set to 3. Okay, then I'm going to go down to Theme Overrides, Styles, Fill, Style Box Flat. I'll change this to a bright green color. And for the background, Style Box Flat, I'll change it to a bright red color. Okay, now let's get reference to some of these in the world script. So at onReadyVar HUD equals, and I'll drag the HUD path in here. Then at onReadyVar health bar equals, and I'll drag the health bar in. And we're going to take the HUD here, and we're going to close this eye here. We're going to make it invisible by default, and then we're going to show it when the player joins. So in both of these, we'll just go HUD.show right after we hide the main menu. HUD.show. Okay, and so for updating the health bar, we're going to have to emit a signal from the player. So I'll go back to the player script over here, and then up top, I'll define the signal. So all the way up here, signal health changed. Then we'll pass in a health value there, and we'll emit this every time the player receives damage. So health changed.emit, and we'll just pass in the health value there. And for connecting it, we'll go back to the world script here. For the server, we'll connect it in the add player function here. So if player.is multiplayer authority, then we'll say player.health changed.connect. And we'll connect it to a function that we haven't made yet, but we're going to call this function update health bar. All right, so I'll copy that. Let's make that function quick. So func update health bar. It'll receive a health value parameter. And then we'll just go health bar dot value equals health value, and that's all we need to do. And for connecting the players in the clients, we're actually going to use a signal from the multiplayer spawner. So I'll go to MultiplayerSpawner Node, then connect this spawn signal to world. And then I'll copy this logic right here that we just made for the server, paste it in here, And then I'll just change player to node. And we don't even need to check to see if it's a player because the player scene is the only thing we're using the multiplayer spawner for. So it should work. So let's take a look. I'll host, and then I'll join here. And it's updating just fine. Okay, what about for the client? All right, it works for both. We could keep adding features and fixes to this all day, but the only other thing that I'm going to address right now is that when a client disconnects, you can see that they still stay spawned on the server, and they would stay spawned on other clients as well. So how do we take care of that? Well, it's pretty simple. I'm just going to go back to the world scene, and we're going to handle it to a similar way in this host button pressed function here with this peer connected signal. Well, guess what? There is a multiplayer.peer disconnected signal. So we're going to connect that to a function called remove player. So I'll copy this, and then I'll go under the add player function here, func remove player. This one also passes in a peer ID, so I'll say var player equals get node or null string peer ID, because the players are named after their corresponding peer IDs, and then I'll check if player. So if this is not null, then player.queueFree, and this should just work. Yep, you can see it's cleared on the server, and the multiplayer spawner, I believe, handles just clearing that on the clients as well. All right, so how do we actually connect with our friends over the internet to play this game together? Well, at the bottom of the world script, I'm going to make some room here, and I'm going to make a function func UPnP Setup var UPnP equals UPnP.new. And first we're going to discover our UPnP device. So I'll make this here. Your UPnP device should be your router with UPnP enabled. It's a setting in your router settings. And for me, it was disabled by default. I think it's enabled by default on most, but it's probably something that you want to double check either way. And we're going to be throwing some errors in this function here if anything goes wrong. So the first thing that we're going to check is make sure that this discovery is successful. If not, we're going to print an error code. And I'll show an example of this failing later and what you might do there. Anyway, moving on. We're going to check next that it's a valid gateway using these functions here, and if it's invalid, then we'll just print an error that it's an invalid gateway. And then after that, assuming this stuff all works, we need to create the port mapping that does the automatic port forwarding. This is the nice thing about UPnP. And if that port mapping doesn't work, we want to make sure that we print an error here as well. But if this all works, this means that UPnP should be set up and people should be able to connect to the host. So if that does work, then we're just going to print a success message here. And this is going to also print the external facing IP that people should be able to type in that join address field, and then join the game. So let's take a look at this. Well, first we actually need to set this function up in the host button pressed. So after the player's added, I'll do UPnP setup right here. Okay, so let's start this up, then I'll click host, and this probably takes a second to set up. Okay, so it actually failed. So I don't have UPnP enabled on my router right now, and you can see here that discovery failed, error 27. And so if I go over to the Godot documentation, I can go to the UPnP page here, and then I can go down and I can see all of these error codes down here. So if I go down to 27, this one says UPnP result no devices. So it wasn't able to find my device. And so for me, that's because the setting's not enabled. But let me enable it, and then let's see what happens. Okay, so now I've got UPnP enabled on my router, so let's try hosting this again. Should go a little bit quicker this time. And there you go. You can see that it actually joined properly this time. And I didn't actually print my full address. I'm just printing a random digit because I don't want to display my external facing IP address to the internet. But this is working. So if you removed this, it would print the entire join address, and then you could hand that off to your friends. And speaking of which, we are just going to go back up here to this create client up here, and we're going to now remove the hard-coded local host here, and we're going to change this to address entry.text, so that now people will enter the IP address here, click join, and they'll actually be able to join it over the internet. So now we just have to export this. Okay, so now we need to export the project. So I'll come up here to project, export, and I'll add, and I'm on Windows, so I'm going to export to Windows Desktop. If you don't have any export templates downloaded yet, this menu should greet you with a message that you don't have any, and it should lead you right to a place where you can easily download them. But anyway, I've already got mine downloaded. So here, I'm going to go here and I'll set the export path to, I'm going to create a folder called exports. I'll save that. And here I'm going to export debug only, export project, and I'll call it FPS prototype.exe, export with debug checked. We want to make sure that we're exporting with debug here because currently the console log is important. The host receives error messages and their external facing address through the console, so we want to export with debug. So I'll save that, and it exported. Okay, so I've got my export directory here, and I'll typically just highlight everything here and send it to a compressed folder just like that, and then I'll share this folder with my friends. And then whoever's hosting, you're probably going to want to open it with this console here, so that this way your external address will get printed here when you set up the host, or it'll print an error if something goes wrong. But otherwise, you just need to forward that address along to anybody who wants to join. They can paste it right in here, click join, and you're good to go. Thanks for watching, and hopefully you learned something. If you enjoyed the video, feel free to subscribe to the channel or follow me on Twitter. It's always appreciated. Thanks again, and more big tutorials to come in the future.